This lesson is going to be on a new topic that is called momentum and impulse. The objective of this lesson is to be able to calculate the momentum as a vector property of an object or system. So first off, momentum is basically a property of any moving object. Okay, the formula for it is the mass of the object times the velocity of the object. We use the letter P to signify momentum. Don't ask me why, we just do. So we use the letter P to indicate momentum, and P is just going to be mass times velocity. Notice the arrow above the letters P and V, okay? That indicates that this is a vector. The units for momentum are going to be kilograms for the mass times the meters per second for the velocity. Later on, we're also going to find that it has another form that we can use, which is newtons times seconds. Okay. The key thing to remember from this slide is that momentum is a vector. Pay attention to the direction. Anytime we have vectors, the direction is important. So, for example, I have a 0.60 kilogram ball and it's moving to the right at 5 meters per second. When it strikes the wall and bounces straight back at 4 meters per second. Okay, so let's draw the picture before we do that. So here I have a ball, it's moving to the right, hits a wall, and then at some point it bounces and goes back. So since velocity and momentum are a vector, I have to choose a positive direction. So since I started going to the right, might as well choose that as my positive direction. So the ball's momentum before hitting the wall is my mass times velocity, 0.6 kilograms times plus 5 meters per second, or effectively just 3 kilograms times meters per second. After it bounces back, okay, I need to remember that that 4 meters per second going to the left is in the negative direction. So my momentum is now going to be 0.6 kilograms times minus 4 meters per second, or minus 2.4 kilograms times meters per second. Since it's just one-dimensional, I don't have to worry about I hats and j hats or anything like that. It's just 3 kilograms in the positive direction, 3 kilograms times meters per second in the positive direction, minus 2.4 kilograms times meters per second in the negative direction. We're also going to be interested a lot in the change in momentum of an object, okay? Because the change in momentum is going to signify that a force was applied to the object. In the case of the ball and the wall applies a force to the ball, making it bounce backwards. And so remember that the change in momentum, or the change in any quantity, is the final version of that quantity minus the initial version. So for change in momentum, it's final momentum minus initial momentum. Okay. So let's look at that same example of the ball, and let's calculate the change in the ball's momentum now. Okay, so remember my initial momentum was 3, my final momentum was minus 2.4. So if I wanted to calculate the change in the object's momentum, it's just final minus 2.4 minus the positive 3. And I end up with minus 5.4 kilograms times meters per second. And that's the change in my momentum. Okay, thank you.